In the last video, I told you that this get method is a blocking method. When we call it, the current thread has to wait until the result of this task is ready. So even though we're executing this task in a separate thread, we're making the current thread wait for the completion of that thread. We are not using our threads properly. We are wasting our threads. Now, this is a very simple application. This is a command line application. But if you had a mobile or a desktop app, this main thread would be responsible for handling the UI events, such as mouse clicks and keystrokes. So if we make the main thread wait for the completion of another thread, it's not going to be able to respond to the UI events. The application window is going to freeze, and the user is not going to be able to resize or move it. So to get the most out of our threads, we should write code in a non-blocking way. And that is what we call asynchronous programming. Asynchronous is one of those fancy computer science terms, but basically it means non-blocking. This code that we have here is synchronous code. It's blocking. We want to write code in a non-blocking way. Now, as a metaphor, think of a restaurant. When you go in a restaurant and order your food, the waiter comes, takes your order, and passes it to the kitchen. Now, he doesn't have to sit there, wait for the kitchen to prepare your food before serving another guest. He can go serve someone else in the meantime. So that waiter, that resource, is like a thread in our application. We don't want to make our main thread or another thread wait for the completion of another thread as much as possible. So we want to orchestrate our tasks such that when a task completes, another task can get executed asynchronously. In 2014, Java gave us a new tool for implementing this kind of applications, asynchronous applications. We're going to look at that next.